Have you ever found yourself stuck on a programming assignment, feeling like you're going in circles? It can be incredibly frustrating, right? If that's you, then you're in the right place. Today, we're diving into how to generate all possible binary trees using Prolog. I totally get it. When you're trying to define a binary tree and it only returns certain structures, it can feel like you're missing something crucial. You're not alone in this struggle. Many programmers face similar challenges. Here's the specific question we're addressing today. One user asked, "Why does my definition of a binary tree not return all possible binary trees when called as ES_ARBLE_X?" They noticed that their function only produces trees that grow through their right nodes. Sound familiar? Let's explore this together. So, what could be going wrong? The user's definition seems valid, but it might be too restrictive. We need to understand how Prolog constructs trees and why it might be favoring one structure over another. Let's break it down. And stick around. By the end of this video, you'll have a clearer understanding of how to define a more general binary tree in Prolog, and I promise it will be worth your time. To address the user's question, we first need to understand why the current definition of a binary tree only produces trees that grow through their right nodes. The user's definition is limited because it does not account for all possible configurations of left and right subtrees. Next, we can modify the definition to allow for more flexibility in constructing binary trees. This involves changing the way we define the relationship between the left and right subtrees. Now let's implement this new definition in Prolog. The user should replace the existing definition with the new one and then test it by querying for all possible binary trees. Finally, the user should explore the results of the query. They will see a variety of binary tree structures, demonstrating that the new definition successfully generates all possible configurations. Fun fact, did you know that binary trees are not just used in programming? They're also used in data structures like heaps and binary search trees. Trees are everywhere. Now, let's look at the answers provided by other users. An alternative approach to generating all possible binary trees in Prolog involves using DCG notation. This method allows you to define the structure of trees while counting symbolically with lists instead of integers. For example, to find all trees with exactly 2 inner nodes, you can query with a list of 2 elements. This allows for a structured way to explore different tree shapes. Additionally, you can use iterative deepening to explore all tree shapes by varying the length of the list. This method provides a systematic way to generate binary trees. Here's a pro tip. When working with recursive definitions in Prolog, always consider how you can expand your base cases to cover more scenarios. This can save you a lot of headaches. And there you have it. With this new definition, you should be able to generate all possible binary trees in Prolog. Remember, programming is all about experimenting and learning. If you found this helpful, hit that subscribe button for more tips and keep coding.